Next feature is the keyway cut for the spindle. Using a gauge pin in the hole. Stand it up, indicate the location. Once you've successfully broached out the slot for the rack, this is what we're shooting for. This control gear right here will ultimately sit down inside this casting and be the drive mechanism that raises and lowers the drill or whatever you have in there. This way. What I'm doing now is by actually using the gear and advancing the table, which moves the piece that way, we can adjust the backlash on this particular gear. I'm going to set the digital at 0, and you can see the amount of backlash that is currently present. That is a 1/10 of a millimeter movement, 3.5 thousandths. I'm just going to keep tapping it in until I like what I see. Then I will rotate the gear up, rotate it, and put it back in, just to make sure that the bore is concentric to the PD and I'm not going to have a tight spot somewhere. Some backlash is good, but you don't want too much. You never know. Well, strangely enough, there's no dimension on the print for this. And I was quite surprised at that little detail. So keep this setup in mind. This is a great way to determine exactly where your gears are going to mesh. And if all goes well, the number that you come up with will put you in the middle of this boss for cosmetic purposes. Believe it or not, it's actually easier for me to look at the camera and do this than it is to look at the part. The image on the camera is about 3 times the size of what I'm looking at. I like it right where it is. It is about 0.33 millimeters worth of movement, 12 thousandths of an inch from the initial contact. Everything is nice and smooth. Very pleased. Okay, now just shift over, visually find the center of this, and off you go. Now, I would have to say, of all the features on this that may not visually align for you, this is going to be it. You want this to be functional above all else. Top to bottom, vertically, this can align fairly well because it's done by eye. But as far as the front to rear is concerned, that's driven by how this is formed, how the casting is oriented. So if this doesn't line up, don't let it break your heart. I'm sure mine will be off somewhat. And there's also a boss on the underside that is, you're at the mercy of the universe on that one. So we'll have to see how that looks when I take it out. And it's not coming out until all of this work is done. So let's ream it, move on. Got the center of the cutter on the center of the pin. I am coming up with the table ever so slightly. And believe it or not, you can do the table with your leg if you position the handle correctly. Just lean on it with your knee. I've always thought that's why they call it a knee mill, because you can raise the table with your knee if you don't have three hands. Raise it until you feel it dragging the paper. When it gives you some resistance, you know you're a couple thousandths away, and it's safe to set your zero. Don't forget that you're working from the center line of the pin and not the tangent. So now once you've established edge planar relationship, drop down the diameter, or excuse me, the radius of whatever pin you're using. This is a 250 pin, 125 down, about 3 millimeters. And I know somebody's probably going to say it, but I'm going to beat you to it. If you know that you're already 125 above center, well, you can just do the calculations for the flats that you want to go to. But I'm just going to go from a true zero and raise the table. Excuse me, drop the table. See some porosity showing through on the finished surface there. I stayed clear of the boss with the exception of taking the top. And the cutter does need to come up to do the top of that, so be careful not to deck the whole thing off to shoot yourself in the foot. I'm going to move back over to my 0-0 position and plunge a counterbore down here to clear the gear. Then I can actually test the gear to see if it worked out. Space permitting, I will make this counterbore a little bit deeper so I can put a Delrin shim under that gear to avoid the metal-to-metal contact that I'm so passionate about eliminating. Kill that for you. There you go. 250 deep, 6 millimeters. pull the fixture out of the machine, let's take a quick look at the alignment and concentricity of everything and such. I like the concentricity of the Spindle journals. The top one is about as dead on as you're going to get. These guys here are acceptable. I would say that the front is probably closer than the back, but you got to draw the line somewhere, because if you try to center this one up, then this one back here jumps out of whack and such. So figure out what's important to you and stick with it. My alignment for offsetting these two guys seem to work very well and bring in the top two as well. But flip side is somewhat of an eccentric relationship here. Left to right you can control, that can be done by eye. And a lot of what you're seeing here is reflection. So left to right is very close, but you can see front to rear has stepped back. The only way to correct that, the only way to center that would be to have the forging or the casting shifted. If it were to shift, you'd lose concentricity here, and this hole would go to the low side because it would pivot up. So you would lose your concentricity back here. This is a real balancing act. This piece is a whole lot more technical than I had initially thought. Yes, it has voids. I will figure out what to use. Before you leave a comment on what to stick in there, review the comments, because I'm sure there's going to be about 7,000 comments that say 5 different things. This little feature right here is for a hook that has the handle. It's a handle rest for whatever. I don't know if you take the handle off and put it on there while you use the power feed or whatever. Because one side of this has a big handle on it that you saw me make before, and the other side of this has a wheel that drives it down using the internal gear in there. So there's 2 gears here. There's one inside buried for the rack, and there's one on the outside for the handle. Before I take this out of the fixture, I'm going to spot face this and put the hole in there that will ultimately hold a hook for the handle. And I'm going to confirm and reestablish that the oiler buttons on top are on the same plane. That way, if I ever have to put this thing back in, I can use those 2 small surfaces as a reference to square this up quickly. Not a bad idea. And that would be just about all there is left to do. So I'm going to dust these off, pop a hole in that off camera. It's going to be boring, but I'll do it. And as far as this is concerned, I know somebody's going to comment that the casting didn't clean up. And you're absolutely right, the casting did not clean up. But let's jump down the line a little bit here. This is not going to be left in a square format like it is. I'm going to make a bead out of that. I'm going to put a large radius on that other corner so it looks like a bead in between the brass column and the upper frame. So that should be consumed by the radius I'm going to stick on there. Should be. If not, then well, I'll just take a dust cut off of that, clean it up, and add whatever I pull off the bottom here to the column. Problem solved. The overall stack height will be the same. That would be considered an assembly level dimension, which is awesome. So if you're an engineer, don't have 15 things held within a micron. Put a stack dimension on it and hold the very last piece. Simple. All right. Let me wrap that up real quick. We'll pop it out, turn it over to the back side. Next piece of line this morning is part number 23. That is the spindle feed shaft. This guy right here. Now this is an extremely clever design. Got a gear pressed on both sides, and this whole mechanism feeds through the whole counterbore that I just put in the frame. 3 different handles get connected to this. You have one large handle on the outside, which is a direct feed. A lot of torque, a lot of mechanical advantage, and it's direct. If you turn this 90 degrees, that gear turns 90 degrees. Therefore, you get a lot of motion on the controlling rack driving the spindle up and down. First option. Second option is the hand wheel in the back. As you turn the hand wheel 1 complete revolution, you will get 1 complete revolution of this gear, translating to the same distance here, but maybe a little quicker. All right, so you got speed, you have torque, and on the front half, this mechanical system right here is another worm gear. 1 revolution of the front handle will give you 1 tooth advance on this. So this is an extremely fine mechanism here. This is also slotted so it can be moved up out of the way and not have to be engaged at all times. Speed, torque, fine feed. Clever, really clever, I like it. The only prerequisites for this part, that this 125, 124 diameter pass through the small hole in the back of the counterbore, and the large diameter must fit in here comfortably to give it the 2 points of reference so that it sits still and doesn't flop around when you engage it. Just grab a piece of material, put it in the collet, get after it. Due to the thin and small diameter double-ended nature of this part, I am going to back turn the majority of the rear side features before flipping it around for finishing. Let's see how that works out. Anytime you reverse turn anything that's a small diameter to a small diameter and you chuck or grip or collet on the other end, you can be assured that you're probably going to get the best concentricity, but you're probably going to get a little bit more chance of this deflecting as well. I'm going to hold it on the bigger diameter, and I'm just going to intentionally throw this in here crooked. Let's see if I can do that. Just to illustrate a point. See the run out, I hope. When gripping on a small diameter like that, you really have no linear point of reference. So by oscillating the part, move the part around as you draw the collet closed. You'll feel little ticks, little gentle ticks. Make sure you move your fingers in a circular motion. When you have it locked down and there's no more ticks, let's see if it runs truer this time. Much better. Third option is to keep it running while you're closing it, while you're floating it in. That way you get the best of both worlds and you get the visual immediately. I'm going to go a little higher RPM to do that. This is about 240 RPM. I'm looking down at a very black line between my bedways and my chip bin, so I have a nice crisp edge I can reference this to. I hope the camera can pick it up as well. That is probably the best of both worlds. All I'm going to do at this point is establish the overall length, and then the end here becomes my zero for all my turning work. I just absolutely love the way this material cuts, taps, finish. This is cold roll, but I believe it's a 1218, 12L18, 1218L. Not the 1018. The 1018 gives you a miserable finish. The 1200 series is just wonderful, man. I love it. I don't work with a lot of it, but it cuts a lot like 303 stainless, but a lot softer. Gives you a great surface finish and easy to cut. High speed just eats it up. If anybody knows for sure what this material is from PM Research, put it in the comment line. Okay, back over to the indexer. Got to put the square on this end, and this part is complete. There you go. And the moment of truth. This is what the part looks like. It is extremely small. Well, not extremely small, but small enough. Got a square drive on both ends, and we got to put bearings right in the middle of the ends. One here and one on the other side of that. They are actually turned larger than the adjoining journals. You can just barely see it in reflection. Be a 1/1000th press fit. Should walk in there pretty easy. Should. Operative word. So gentle tap. Okay, with it started, I am going to put it in my vise, squeeze it end to end, and then we'll try it. There's no relationship between the teeth and the squares on the end of the teeth to each other. Nothing. So if you can get this thing to go together, have at it. Let's move it over to the vise, give it a squeeze. A gentle squeeze. This is what the completed subassembly looks like. Gears pressed on. The little Delrin washer is on there that I put in there. This is 20 thou deeper to allow for the thickness of that washer. Let's pop this in there and give it a go. There you go. That's going to be really hard to do without blocking out the light. I'll give it my best shot, but you can see now when the handle turns, and boy, that is nice and smooth. It'll drive the spindle drive collar up and down. This spindle will be rotating. It'll be trapped on either end of the brass component with a collar with a set screw, so it can continue to rotate while the collar will move it up and down. And that is quite enough for one episode. I'll make the bushings and the handles and try to get this thing getting a little closer to done. It is very close as it is. And for anyone that wants to see the back side of this, I'll show you. I think I'm hiding anything here. The concentricity of the hole to the boss on the back side, you can see where it ended up. Now, there are several reasons for that, depending on how this thing is positioned in the fixture, depending on how the casting itself was positioned side to side. There's a million different things that could cause that, and you know, it is what it is. When it comes to lining up all of these other features, I nailed it, and if I got to eat one, so be it. It's a win. I'm going to put a bushing on there with a flange on it, dress it up cosmetically a little bit, but that way you'll know you have an original. If you get one that's off center like this, it's mine. Oh well, it is almost Christmas. There you go. That's all I got for you. I hope you enjoyed that episode. It was a lot of work to do this one. This was a very delicate little mechanism. Wherever you are in the world, I hope you are well and safe. This is Joe Pye at Advanced Innovations in Austin, Texas. I'm out.